How are you, my friends? This is another lecture in Algebra course, lecture 23 about complex numbers. These are very important in many math courses and also in engineering. So here we will add, subtract, multiply, and divide complex numbers after we make some definition. This is the objectives. You can read it. See this addition, subtraction, multiplication, division, complex conjugates, and all this. Now, definition, what is a complex number? Complex number is a number in this form, a plus bi. A is called the real part, b is called the imaginary part, only the b without the I is the square root of -1. And when you square it, you get I squared is equal -1. So all this number, we call it in standard form, is a complex numbers. These are examples here you can read and see. Now, when two complex numbers are equal, clearly they are equal if the real part is equal to the real part, like A equals C here, and the imaginary part is equal to the imaginary part, so B equals D. So these complex numbers are equal. See, 10 is the real, 10 is the real, imaginary. This one is not equal because X is the real part here, the real part is Y, they are not equal. Let's look at example 1. Find m and n if the equation is true. Then find m plus n. So easy. We say the equation here is true. That means this is the real part, 2m minus 7 is equal to 4. And this is the imaginary, 3n plus 8 is equal to -5. So we can make simple equations. So the real part is equal to real part. So I take 2m minus 7 is equal to 4. I find m is equal to 11 over 2. Imaginary part, 3n plus 8 is equal to imaginary part -5. So n will be minus 13 over 3. Find m plus n, just add the numbers. 11 over 2 minus 13 over 3. We need LCD 6. So this will be 33 minus 26 over 6, 7 over 6. Now, when you have negative numbers under the radical, it's not a real number. So one rule you can use, square root of minus a is I square root of a. All these examples you will see now, many examples. It will be about this rule, square root of minus a, I square root of a. Look at this many examples, square root of minus 9, I square root of 9, but we can simplify square root of 9. So 3i we write here. This one, square root of minus 16, 4i. Square root of minus 8, see we cannot simplify the 8. So we write I as this one here, square root of 8. Then 8 will be 4 times 2. So the final answer will be 2 square root of 2. I is outside here. Square root of minus 7. I square root of 7 or square root of 7i. Just be careful. If you have a cube root, that's a real number. It's not a complex number. Now, let's look at the value of this. Maybe you can try it yourself and see square root of minus 2 times square root of minus 3. I think many people will say square root of, you multiply the number square root of 6, which is wrong. Why wrong? Oh my goodness. Square root of 6 is wrong. Yes, wrong. Because square root of minus 2 is I square root of 2, and square root of minus 3 is I square root of 3. That will be I squared here. So I squared is -1. Minus square root of 6 is the correct answer. Now, if you have one of them is complex, you have to leave the I, you see? And this is square root of 3. Now, what can we use this one? Square root of A times square root of B is equal to square root of AB. If A positive and B positive, that means the real numbers. Now, operations. We start with addition and subtraction, which is so easy. Then we move after that to multiplication and division. So adding, you don't have to memorize these formulas, guys. It means here, if you have a complex numbers, 2 or 3, you need to add them. Just add the real parts and then add the imaginary parts, and there is an I with it. Subtraction is the same. A minus C, and then B minus D times the I. Everything times the I will be the imaginary part. Without the I will be the real part. Let's look at this nice question here. Let's write it in standard. So all this, we need 3 brackets here we have. See, I put one question, something plus something minus something. Be careful here. What do we do? Be careful. 5, we leave it. Cube root of 27. Remember, this is real number. There is an I in the question. Square root of minus 1 is I. This one is a real number, only 7. This one is 8I. So just be careful. What do you write here? 5, we leave it. Cube root of 27 is 3. So this is 3I plus 1 minus 9I. See 1 minus 9 minus square root of 49, only 7. It's a real numbers here, real numbers. See real numbers here, complex numbers here. Square root of minus 64 is 8I. See, there is a plus outside. Now you multiply with the minus, change all the signs here. And this is a plus, we don't change the signs. So when you add everything, you get 5 and 1 and minus 7. So that's minus 1. 3 minus 9 minus 8, so that minus 14I. This is the standard. If we ask you find the real part, it's minus 1. Find the imaginary part, it's minus 14 only. Now let's see example number 3. I think I can leave it for you. It's very nice example. Same as example 2, just more numbers. You can practice on it. Nothing is new. Look at the radicals and do it. This is equal x plus yi. Find x, find y, multiply. You can pause the video, please, and try it. So nice. Maybe the important part here is this cube root of minus 1. So that is minus 1, also real number. See, I put 2 slides for this one in details. This is a minus 1. You can try. This is cube root of 125 is 5. LCD. Try it yourself. And then you find x minus 3 over 2. Y will be 1 over 6. Multiply them. You get minus 1 over 4. Just one remark here. If you get this answer, please, minus 3 over 2 plus 1 over 6i, you can leave the minus here on the side. You can put the minus with the numerator, or 1 over 6i, you can write it as I over 6. These green answers are the same exactly. Now let's multiply. We multiply using FOIL method. So you didn't have to memorize any formula here. 5 minus I, 3 minus 2i. Just multiply. 5 times 3, 5 times minus 2i, minus I times 3, minus I times minus 2i. The only problem here, you know what is the problem, right? Only the signs. Look, minus I times minus 2i, it will be plus 2i squared. And we know I squared is minus 1, so that's minus 2. So 15 minus 2 will be 13 minus 13i. Let's look for another example. Minus cube root of minus 8, 3i, 4 minus 7i, I cubed, square root of minus 81. The moment, let me advise you here, the moment you see radicals, cube root, square root, make sure to tell yourself, this is real, this is complex. This is real, this is complex. Now this one is real here, you see the cube, the index odd, that's a real. This one is complex. And now you try it. This one is minus 2. You see the cube root of minus 8 is minus 2. And there is a minus outside, so that's 2 only. 2 plus 3i, this is 4 minus 7i. I cubed is, see, I explained here why. I cubed is minus I. 13 minus square root of minus 81, it's 9i. And there is a minus c from the question. Just multiply everything here, you get 20 minus 15i. So easy. Conjugates. If you have a complex number z, a plus bi, if I ask you find the conjugate, we call it z bar or z dash. The conjugate is z bar. It's a, we change the sign of the imaginary only. So a minus bi. Just remember this definition. That's the definition. So these are 3 examples here. If z is equal 9 plus 20i, the conjugate 9 minus 20i. If we have this one, see the imaginary here, minus 48. So when you find the conjugate, it will be plus 48i. And this real part will stay the same. So we only go for the imaginary part. X minus yi, the conjugate, x plus yi. STS. STS, this name, I found this name. It means sum of two squares, STS. There is no name actually for this formula, but just to make it easy for the math users, they can say a plus bi, a minus bi, multiply a and a squared. Remember here there is bi and minus bi. So it will be minus b squared, I squared, which is plus here. So that's why we say sum. Go down, 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 the last line. Look at this one, recall this. This is in your mind. A plus b, a minus b is a squared minus b squared. This is real numbers. This is complex numbers. So in the complex numbers, we have a squared plus b squared. In the real numbers, we have a squared minus. Just memorize these, understand them, and apply them. 3 plus 2i, example here, times 3 minus 2i. You can figure it out. 3 and 3, directly take 3 and 3, square it. 2 and 2, square it. Everything will go. 13 is the answer here when you multiply. You can do it in your paper, please. Try to multiply this 1 time or 2 times until you get 13. Then you know what is the meaning of the formula. Write the complex number in standard form. All this big complex number. See, when you have multiplication, you have to multiply up, you have to multiply down. Now, we know I squared is minus 1, so minus 1, this is plus 1. Now let's look here. Are these conjugates, are these the same as this formula here? You have to check. Minus 2 is real and real. Minus 5i plus 5, yes, conjugates. Are these conjugates? 1 plus I, 1 minus I, yes, conjugates. So apply STS here, apply STS down. See, directly here, it should be positive number, remember. STS formula is positive number, a squared plus never becomes here minus. So minus 2 squared, 5 squared, so that's 29. And there is a minus 1, as I said, this is plus 1. So that's 20, minus plus, so that's 30, over 2 is 15. See, there is no I, so we put 15 plus 0i. Okay, so that's a plus 1 here. Now, this example 6, see this example 5, very similar. I put one single thing different. One single thing different here. This is conjugates, let's check. This is conjugates, yes, same question. This one conjugate? No. 1 plus I minus 1 plus I. That's the only reason I put example 6. So what can you do here? You take, this is Z, I need Z conjugate. After you multiply, you simplify all this Z, find the conjugate of the Z bar here. Now, look at this trick. You can multiply normal if you like 1 times this, 1 times that, I times this. You can multiply normal, that's correct. Or take a minus 1 only from the second one, common factor. Then becomes 1 minus I. See, this is what I did here. I take a minus common factor, so I put it here. And then this becomes 1 minus I. We have seen this many times. Now these are conjugates. So 1 squared plus 1 squared. This is the formula for the conjugates. So down we have minus 2. Even if you multiply normal, you will get minus 2. So this is minus 29 over 2 minus half is equal Z. That's Z. I need Z bar, which is the conjugate. So the answer now, the same real part, minus 29 over 2 plus I over 2. That's the conjugate. Now let's divide A plus BI divided by C plus DI. Anytime, let me give you an advice here. Anytime you have division of two complex numbers, you have to multiply by the conjugate of the denominator here, C minus DI, if you have C plus DI. always, 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 always multiply by the conjugate. Now, when you multiply by the conjugate, a plus bi times c minus di, use FOIL method here. In the numerator down, use STS, sum of two squares. Let's take the most important question in this lecture. It's not difficult, remember, it's not difficult, but the most important. All the difficult questions, you have to compare it with example 7, believe it or not. I will show you. If I say here, write the complex number, all this in standard. See, this is 2 plus 3i divided by 1 plus 2i. Write all this in standard form. So what do we do? Multiply by the conjugate. Multiply by the conjugate, 1 plus 2i, 1 minus, this is the only way. And remember, I squared is minus 1. So down we have the formula here, STS, 1 squared plus 2 squared, that's 5. And then this is by FOIL multiplication, you can check it please. So we get 8 minus I. So 8 over 5 minus 1 over 5i. That's the answer, that is the standard. Now you will say, oh, this is easy, I know. But students or math users, they forget to multiply by the conjugate. And you will try and see. Let's take powers of the I. You have to remember the first line here. We know I squared is minus 1. We know I cubed is minus I. It's so easy. And I power 4 is 1. Only these you have to remember. Any other power, see, I put here I to the power 23 or 59 or 61 or minus 100, whatever the power, positive, if the power is positive, divide by 4 and take the remainder. See, I power 23, don't think too much, just take 23, simple numbers here, divide by 4. So the answer is 5 and the remainder 3. So I put I power r. See, directly you can remember this. I to the power n is equal I to the power r. R is, so the remainder here can be 0, 1, 2, or 3 only. So I cubed, you remember this one is in your mind, I cubed is minus I. So I to the power 23 is minus I. Now this will be inside a question. It's not a question by itself, let's take just two simple quick examples. I to the power 102, I to the power here minus 77. This one is easy, although I put all the solutions here. I will spend little time on negative. I to the power minus 77, so it will be 1 over I to the power 77. See, then I divide 77 by 4, which is 19, and the remainder is 1. So I have 1 over I. This is not standard. So I multiply up and down by the conjugate, which is minus I. So 1 times minus I, this is minus I squared, which is 1. See, I to the power minus 77 only minus I. And I to the power 102 only minus 1. You can figure out there in the remainder 2. Now, let's look at a nice example here. See, we have the powers inside the questions. Given the complex number here, see, look at this, all complex number here, all of it is one number here. Find its conjugate. Then multiply them. So this is a complex number here, and the conjugate will be another complex number. Multiply them, multiply the complex after you simplify it by the conjugate. Now you can call it something here. You can call it complex number Z, you can call it X, you can call it Y. I call it W, just to make things easy. Let W, all this is W, same numbers, see? Same numbers. Now let's look at the power in the I, 101. 101 divided by 4, the remainder is 1. So directly, I to the power 101, I write I. I to the power 80 divided by 4, the remainder is 0. I power 0 is 1. So instead of I power 80, I put 1. You see this 1 here? And this is the I there. Now I multiply here until I get W. You can check these numbers, please. 9 minus 12I. That's W now. The conjugate, W bar. The conjugate equals W bar equals 9 plus 12I. Let's multiply them, because the question said multiply them. W times W bar. See, now you can use the formula. 9 minus 12I times 9 plus 12I. So 9 squared, 81, is equal to 12 squared, 144. Okay. Now, this is exam type. Why we say exam type? Because we have power here, 50. We have squared. We have complex. We have division. We have conjugates. We have addition, subtraction, multiplication. Everything is example 10. Everything. See, example 10 is exam type. It covers everything. But the important, I said the most important, remember? The most important was 7. Because many people, many students, they forget to multiply by the conjugate. That's important to remember. Now let's do this. It's easy to do it, maybe 2 slides. I will go slowly, Shab. You have to go slowly. Square root of minus 9, quickly. 3i. I to the power 50, divide by 2. Remainder, divide by 4, the remainder is 2. So minus 1. 2 plus I all squared, put the formula. See, you can take each part and simplify it. 4 plus 4i plus I squared. So it will be 3 plus 4i. Use this formula, the blue formula. Now put everything in the given. You get what? Minus 1. You should get minus 1 plus 4i divided by 2 minus 3i. See this one here? That's similar to what? Minus 1 plus 4i divided by 2 minus 3i. Similar to what? Example 7. That's why I said the most important. Multiply by the conjugate, and then you proceed normally until you get minus 14 over 13 plus 5 over 13i. What was the question? Find the real part and the imaginary part. So we say the real part is this number here, all minus 14 over 13. The imaginary part, 5 over 13 without the I. Now, solve the quadratic equation here. We have seen quadratic equations in lecture 22. Why we are solving here? Because the solutions will be complex. So you can use the best method, quadratic formula. Rearrange the equation, put minus 1 on the other side, find ABC as usual. This is so straightforward. Question A3, B minus 2, C1, find capital D, the discriminant, B squared minus 4AC. Check it yourself. You get minus 8. See, negative now. Negative. Discriminant solutions are complex. So put it here, square root of minus 8, we have I. See, that's why we have this question in this lecture. So square root of 8 becomes 2 square root of 2. Take common factor here. Take common factor into 2, then cancel. So the solution will be 1 plus square root of 2i over 3. 1 minus square root of 2i outside over 3. Now, I will leave for you all the exams questions as a review, as a practice to understand the idea. Z equal this, find Z bar. So nice questions, but after you understand the lecture. Z and W here we have, find all this. See, remember, this is a conjugate, so Z plus W conjugate. So you have to add them, then find the conjugate. This one is very nice. It says nice only, maybe very nice. This is a complex number. Write it as A plus BI. Find the value B over A. See, after you simplify the left side, find A, find B, then divide B over A. Solve the equation similar to the one we did in example 11. Also, if this is Z, all this is Z. Oh, nice question. I know this is heavy, guys. Remember example, this is old exam question number 6. This is Z. After you finish it, you have to find Z times Z bar divided by same Z plus Z bar. I wish you all success in this number 6. Number 7, this is all Z, find Z, Z bar, only the addition. Very nice, there is A and B variables here, you can check. And number 8, we have Z1 is this, Z2 is this. See, this is Z1, this is Z2. Now, find the value of K. So this is what we need here, K, this K. If Z1 over Z2, so this one divided by this, is equal to 2 plus Ki in the bracket Z1 plus Z2 minus Z1 times Z1 bar or dash minus I to the power 94. This is really heavy question. Now let me advise you here, just advice. Simplify Z1, don't replace Z1 here. Remember I told you this advice before? Simplify Z1, make it simple. I will tell you simple, like square root of 9, 3 plus I. So this is simple. Z2, make it the same, simple. Then you can substitute. Now these are the answers here. Question 1, 2, 3, 4, 5, 6, 7, and 8. So this is question number 8, find K. Now if you need the complete solution of all this, you can see the video please on all the exams questions, complex numbers. You will see the details, 8 questions, all the steps. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much.